Germany lost the Second World War, but 5 weapons they built made the Allies afraid in ways no other technology could. These weapons did not win battles through sheer numbers. They won through precision, lethality, and a kind of mechanical terror that lived in the minds of soldiers before they ever encountered them on the battlefield. Each one represented a different answer to the same question. How do you make an enemy hesitate before they even see you? Before we go deeper into how these machines changed the way men fought and died, make sure to subscribe for more history that actually happened. The story begins not with metal or gunpowder, but with doctrine. In the years between the 2 world wars, Germany faced a strategic problem that could not be solved with conventional thinking. The Treaty of Versailles had stripped the nation of its offensive military capability. Submarines were forbidden. Heavy artillery was restricted. The army was limited to 100,000 men. But restrictions breed innovation, and in the shadows of Weimar Germany, a new generation of military thinkers began to reimagine warfare itself. They studied the failed offensives of 1914 through 1918, the grinding attrition that consumed millions of lives for mere yards of mud. They concluded that future wars would not be won by mass alone, but by speed, shock, and concentrated firepower applied at decisive points. This philosophy would shape every weapon Germany produced in the years to come. By the mid-1930s, with rearmament underway and Hitler consolidating power, German engineers received mandates that sounded impossible. Build tanks that could break through fortified lines, design artillery that could destroy aircraft at altitudes no gun had reached before, create submarines that could choke Britain's supply lines across an ocean, develop automatic weapons that one soldier could carry but fire like a crew-served gun. Each requirement demanded not incremental improvement, but radical rethinking of what a weapon could be. And in workshops from Krupp to Henschel, from Rheinmetall to Mauser, men began building machines that would define the character of the war. The 88mm flak gun emerged first, designed in secret during the 1930s as Germany began violating the Versailles restrictions. Krupp engineers faced a dual challenge: create an anti-aircraft weapon capable of hitting bombers flying at 20,000 feet, yet keep it mobile enough to follow rapidly advancing mechanized units. The result was a weapon that defied categorization. The Flak 18 and its refined successor, the Flak 36, measured just over 5 meters in length and weighed approximately 5 tons in firing position. The barrel, 88 millimeters in diameter, could elevate to near vertical angles for anti-aircraft work. The mounting sat on a cruciform platform that unfolded from its wheeled carriage, providing stability when firing. But it was the ballistics that made the weapon revolutionary. The 88 could propel a 9-kilogram shell at nearly 800 meters per second, reaching altitudes of 10,000 meters. Against aircraft, crews calculated deflection angles using mechanical computers, then fired shells fitted with timed fuses that detonated in proximity to the target. The fragments from these airbursts could shred aluminum airframes and kill crews. In 1944 alone, German 88mm batteries accounted for over 3,500 American aircraft destroyed, more than enemy fighters shot down in the same period. But the gun's true terror lay in its unintended capability. In May 1940, during the Battle of France, a Wehrmacht officer named Erwin Rommel commanded the 7th Panzer Division as it drove toward the Channel coast. Near Arras, British Matilda tanks counterattacked his exposed flank. The Matildas carried armor up to 78 millimeters thick on the front, proof against every German anti-tank gun then in service. Rommel's 37-millimeter guns bounced shells off the British armor like stones off castle walls. In desperation, Rommel ordered his 88-millimeter flak guns depressed to horizontal firing positions and aimed directly at the oncoming tanks. The result was mechanical slaughter. At ranges exceeding 1,000 meters, the 88s punched through Matilda armor as if it were paper. Tanks exploded. Crews died before they understood what was killing them. The British attack collapsed. Word spread through the Wehrmacht that the 88 could serve as the ultimate anti-tank weapon. By 1941, every German division in North Africa included 88mm batteries explicitly trained for anti-tank work. Rommel positioned them in concealed firing positions across the desert, often dug in behind low ridges with only the barrel visible. British tank commanders learned to fear the flat crack of an 88 firing, a sound that meant their armor was obsolete at any range the gun could see them. The psychological effect proved as devastating as the kinetic. Tank crews hesitated. They maneuvered defensively. They lost the initiative before the first shot. Production continued throughout the war, with over 20,000 88mm guns manufactured in various configurations. The weapon equipped everything from towed batteries to tank destroyers to the turrets of Tiger tanks. No Allied soldier who faced the 88 ever forgot its sound. But if the 88 defined armored warfare, another weapon redefined how men fought beneath the ocean. The Type 7 U-boat represented Germany's answer to Britain's geographic advantage. Britain was an island. Everything that sustained it, food, fuel, ammunition, raw materials, arrived by sea. Strangle those supply lines and Britain would starve, surrender, or collapse. The Kriegsmarine commissioned the Type 7 in 1935, refining designs that dated back to the First World War. The VKIC variant, which entered service in 1940, became the most produced submarine in history. Over 570 were built between 1940 and 1945. Each boat measured 67 meters in length and displaced 767 tons when submerged. A diesel-electric propulsion system provided 17 knots on the surface, but only 7 knots submerged. The hull could survive depths of 230 meters before risking catastrophic implosion. Range reached 8,500 nautical miles at cruising speed, enough to patrol from German ports to the mid-Atlantic and back. Armament consisted of 5 torpedo tubes, 4 forward, 1 aft, and 14 torpedoes stored in pressure-resistant racks throughout the boat. A crew of 44 men operated the vessel in shifts, living in conditions that defied description. Inside a Type 7, men existed rather than lived. The air stank of diesel fuel, unwashed bodies, rotting food, and the chemical toilets that never quite contained their contents. Mold grew on everything, moisture condensed on every metal surface. Fresh food spoiled within days, leaving the crew to subsist on canned rations and hard bread that turned green with fungus. Men slept in shifts, sharing bunks still warm from the previous occupant. Privacy did not exist. The boat ran hot when submerged, temperatures climbing past 30 degrees Celsius, and cold on the surface in northern waters, where ice formed on the conning tower. Yet these conditions produced one of the most effective weapons of the war. Between 1940 and 1943, U-boats operating primarily in the Atlantic sank over 2,700 Allied merchant ships, totaling more than 14 million tons of cargo. In March 1943 alone, submarines destroyed 693,000 tons of shipping. Individual boats achieved staggering records. U-48 sank 51 vessels totaling over 300,000 tons during its operational life. U-99, commanded by Ace Otto Kretschmer, sank 44 ships before its capture in 1941. The tactics evolved as the war progressed. In the early years, U-boats hunted alone, surfacing at night to attack convoys with gunfire or torpedoes, then diving before escorts could respond. But by 1941, Admiral Karl Dönitz implemented Wolfpack tactics, Rudeltaktik in German. U-boats formed patrol lines across known convoy routes. When one boat spotted a convoy, it shadowed at a distance and radioed position reports to U-boat headquarters in France. Other boats in the area converged on the target. After nightfall, the Wolfpack attacked from multiple directions simultaneously, overwhelming the escorts. Convoy battles raged for days across hundreds of miles of ocean, Merchant ships exploded, their cargoes of fuel and ammunition turning the night sea into fields of fire. Survivors floated in oil-covered water, dying of hypothermia or drowning before rescue arrived. The psychological toll on Allied merchant seamen matched any combat branch. Sailing on a merchantman in the North Atlantic meant knowing that at any moment a torpedo might strike without warning, tearing your ship open below the waterline, giving you perhaps 2 minutes to reach a lifeboat before the vessel dragged you down. Yet the convoys sailed. Thousands of them crossed the Atlantic because Britain's survival depended on their cargoes. But the U-boat war carried its own terrible arithmetic. Of the 39,000 men who served in the U-boat force during the war, 27,490 died in combat or accidents, a 70% fatality rate. 783 U-boats were lost. By May 1943, improved Allied tactics, escort carriers, long-range patrol aircraft, radar, sonar, and code-breaking turned the Atlantic into a graveyard for submarines. Yet for 3 years, Type 7 U-boats brought the world's most powerful navy to the edge of defeat through nothing more than steel tubes carrying desperate men into the dark. If the Atlantic belonged to submarines, the land belonged to automatic weapons, and Germany built one that changed infantry combat forever. The MG-42 machine gun entered service in 1942 as a replacement for the earlier MG-34. Where the MG-34 had been a precision instrument, expensive to manufacture with complex machining requirements, the MG-42 represented ruthless efficiency. Engineers at Mauser used metal stamping and welding instead of machining, cutting production costs and time by more than half. The weapon weighed 11.5 kilograms, light enough for one soldier to carry. But its capability belied its weight. The MG-42 fired the standard 7.92 millimeter Mauser cartridge at a cyclic rate of 1,200 rounds per minute, 20 rounds every second. That rate of fire produced a sound unlike any other weapon, not the discreet crack of rifle fire, but a continuous tearing roar that reminded men of industrial saws ripping through lumber. Allied soldiers called it Hitler's buzzsaw. The nickname was not affectionate. The gun operated through a roller-locked bolt mechanism that absorbed recoil while allowing an extremely high rate of fire. Feed came from a continuous belt that entered from the left side. The barrel could be changed in under 6 seconds by releasing a latch and swinging the receiver to the side, a crucial feature because sustained fire-heated barrels to glowing red within 200 rounds. In defensive positions, German crews pre-positioned spare barrels and thousands of rounds of linked ammunition. A well-trained 3-man crew could maintain an effective rate of roughly 150 rounds per minute indefinitely by firing in short bursts and changing barrels on a schedule. But it was the doctrine, not just the mechanism, that made the MG-42 devastating. German infantry tactics centered on the machine gun rather than the rifle. Where American and British doctrine viewed the machine gun as a support weapon, German doctrine reversed the relationship. The MG-42 was the primary weapon. Riflemen existed to protect the gun, carry ammunition for it, and exploit the suppression it created. In defensive battles, German squads positioned their MG-42 to cover likely avenues of approach with interlocking fire. The gun remained silent as Allied troops advanced, often allowing the first wave to pass, then opened fire into the mass of following troops. The sound alone caused men to freeze or dive for cover. Those who continued forward met a wall of bullets that cut them down in seconds. The MG-42's high rate of fire meant that even brief bursts covered a wide area with lethal effect. A soldier who thought he had moved between bursts often discovered he had not. Casualty statistics reflected the gun's lethality. In Normandy, American infantry units suffered over 70% of their casualties from machine gun fire, much of it from MG-42s. Veterans reported that hearing the MG-42's distinctive sound triggered an immediate, instinctive dive for any available cover. Production exceeded 400,000 guns by war's end. The weapon equipped every branch of the Wehrmacht from infantry to paratroopers to armored units. Its design was so effective that it continued in production after the war as the MG-3, still in service with some armies today. But where the MG-42 represented evolutionary excellence, another German weapon represented revolutionary thinking about infantry arms. The Sturmgewehr 44, Assault Rifle 44, emerged from the same doctrinal questions that shaped the MG-42. German infantry doctrine emphasized fire and maneuver, but the standard Karabiner 98K bolt-action rifle fired a powerful 7.92 mm cartridge designed for ranges exceeding 800 meters. Infantry combat studies showed that most engagements occurred at ranges under 300 meters. The 98K's power was wasted, its bolt action was slow. Semi-automatic rifles like the American M1 Garand provided higher rates of fire, but still used full-power cartridges with significant recoil. Submachine guns offered high rates of fire, but fired weak pistol cartridges effective only inside 100 meters. Hugo Schmeisser and other designers at Haenel proposed an intermediate solution: a rifle firing a shortened, less powerful cartridge that offered controllable recoil in automatic fire while maintaining lethality to 300 meters. The result was the 7.92 mm Kurz short cartridge and the weapon built around it. The Sturmgewehr 44 weighed just under 5 kilograms and measured less than 1 meter in length. It fed from a 30-round detachable box magazine and could fire either semi-automatic or fully automatic at a cyclic rate of 500 rounds per minute. The shorter cartridge allowed soldiers to carry significantly more ammunition than standard rifle rounds. Effective range reached 600 meters in semi-automatic mode. In full automatic, the weapon remained controllable for aimed bursts out to 300 meters. For the first time, a single infantryman could carry a weapon that combined the sustained fire of a submachine gun, the accuracy of a rifle, and the range to dominate typical combat distances. The concept was so radical that it almost never reached production. Hitler initially opposed the project, believing Germany needed more submachine guns and standard rifles, not experimental hybrids. Designers and field commanders circumvented the order by classifying the weapon as a submachine gun, Maschinenpistole 43, and continuing development. Field trials on the Eastern Front in 1943 proved the design's effectiveness. Troops equipped with the MP-43 could suppress and maneuver more effectively than units with standard rifles. They carried more ammunition. They needed less training to achieve combat effectiveness because automatic fire compensated for poor marksmanship. When Hitler finally saw the weapon demonstrated, he recognized its potential and approved full production, personally giving it the name Sturmgewehr, assault rifle. The term defined a new category of infantry weapon. Production began in 1943 but never reached the scale Germany needed. Manufacturing priorities, resource shortages, and Allied bombing limited output to roughly 450,000 rifles by war's end. Those that reached frontline units proved their worth. Soldiers armed with the STG-44 in defensive positions could hold off numerically superior forces. In offensive operations, assault troops using the rifle could advance while firing, suppressing enemy positions without stopping to aim carefully. The weapon influenced post-war small arms development worldwide. The Soviet AK-47, the American M16, and virtually every modern assault rifle trace conceptual lineage to the STG-44. But while these weapons changed how individual soldiers fought, Germany's final terror weapon changed warfare itself by removing humans from the battlefield entirely. The V-2 rocket was not a weapon in any conventional sense. It was a ballistic missile, the first operational long-range guided weapon in history. Development began in the 1930s at the secret Peenemünde research facility on Germany's Baltic coast, led by Wernher von Braun and a team of engineers who imagined rockets as vehicles for space exploration. The military saw a different application, a weapon that could strike targets hundreds of kilometers away with no defense possible. The A-4 rocket, later renamed Vergeltungswaffe II, Vengeance Weapon 2, measured 14 meters in length and weighed over 12 tons at launch. The body contained ethanol and liquid oxygen in separate tanks, feeding a rocket engine that produced 25 tons of thrust. Guidance came from a gyroscopic system that adjusted the rocket's attitude during powered flight. The warhead held approximately 1,000 kilograms of amytal explosive. Launch procedure was complex and required a crew of specialized technicians. The V-2 sat on a mobile launch platform that could be positioned, fueled, armed, and fired in under 2 hours before moving to avoid Allied bombing. Once ignited, the rocket rose vertically on a pillar of flame visible for dozens of kilometers. Within 1 minute, it reached supersonic speeds. The engine burned for roughly 65 seconds, accelerating the weapon to over 5,500 kilometers per hour before cutting off at an altitude of 80 to 90 kilometers, the edge of space. The rocket then followed a ballistic trajectory, arcing downward to strike its target approximately 5 to 6 minutes after launch. No aircraft could intercept it. No radar could track it in time to provide warning. No defense existed. The V-2 simply fell from the stratosphere at 3 times the speed of sound and detonated. The sound of the explosion arrived before the sound of the rocket approaching. Victims heard the blast that killed them before they heard the weapon that caused it. Germany began operational V-2 attacks on September 8, 1944. The first rockets struck Paris and London on the same day. Over the next 7 months, approximately 3,172 V-2s were launched against Allied cities. Roughly 1,500 hit London, killing an estimated 2,700 civilians and injuring 6,000 more. Antwerp, Belgium, a critical Allied supply port, suffered over 1,500 V-2 strikes that killed 3,700 people. Unlike conventional bombing, the V-2 provided no warning. People died while shopping, walking to work, sleeping in their beds. Buildings collapsed without the sound of aircraft engines or air raid sirens. The randomness amplified the terror. You could not hear it coming. You could not take shelter. The rocket struck, and you either survived or you did not. Yet for all its technological achievement and psychological impact, the V-2 was militarily ineffective. Each rocket cost as much to produce as a fighter aircraft, but carried only 1 ton of explosives, less than many conventional bombs. Accuracy was poor, with most rockets landing hundreds of meters from their aim points. Strategic effect approached zero. The resources devoted to V-2 production, scarce fuel, precision components, skilled labor, would have produced far more military value if invested in fighters or tanks. Over 20,000 concentration camp prisoners died building V-2s in underground factories, more deaths than the weapons themselves caused. The V-2 represented the dark side of innovation, technological brilliance divorced from strategic sense, a weapon built because it could be built, not because it should be built. But it established the template for every ballistic missile that followed. ICBMs, submarine-launched weapons, space launch vehicles, all descend directly from the V-2. The engineers who built it went to America and the Soviet Union after the war and designed the rockets that would take humans to the moon and hold the world hostage during the Cold War. These 5 weapons, the 88mm gun, the Type 7 U-boat, the MG-42, the Sturmgewehr 44, and the V-2 rocket, shared a common characteristic. Each represented a doctrinal shift, not merely a technical improvement. The 88 was not just a bigger gun, it was a weapon that could perform roles no single weapon had performed before. The U-boat was not just a submarine, it was a strategic weapon aimed at national survival, rather than tactical victory. The MG42 was not just a faster machine gun, it restructured how infantry fought. The STG-44 was not just another rifle, it created a new category of infantry arms. The V2 was not just a long-range weapon, it made defense irrelevant. Germany built weapons that forced enemies to adapt or die. But innovation alone does not win wars. Production capacity wins wars. Logistics wins wars. Resources win wars. Germany produced approximately 1,500 Tiger tanks. The Soviet Union built over 50,000 T-34s. Germany manufactured 450,000 Sturmgewehrs. The Allies produced millions of M1 Garands and Lee Enfields. 783 U-boats were lost, taking 27,000 submariners to the bottom. The Atlantic convoys kept sailing. 3,000 V-2 rockets struck Allied cities. 500,000 tons of Allied bombs struck Germany. The mathematics were inexorable. Fear is a powerful weapon, but it cannot overcome industrial capacity, manpower reserves, and global resource networks. Every one of these weapons proved that skill and innovation could multiply effectiveness, but multiplication still depends on what you begin with. When you begin with less territory, fewer allies, smaller population, and limited resources, even the most feared weapons cannot close the gap. The legacy these weapons left was not victory, but transformation. Modern main battle tanks carry guns that can engage air and ground targets because the 88 proved the concept. Every Navy operates submarines because the Type 7 showed that underwater warfare could threaten national survival. Machine guns with quick-change barrels firing at high cyclic rates equip infantry worldwide because the MG42 demonstrated the doctrine. Assault rifles firing intermediate cartridges are standard issue for virtually every military because the STG-44 proved the design. Ballistic missiles form the foundation of nuclear deterrence because the V2 showed that rockets could reach across continents. Germany lost the war it started, but the weapons it built defined how all future wars would be fought. The tools of terror became the tools of victory for those who learned their lessons. History is written by the victors, but weapons are remembered by everyone who faced them. Please don't forget to like, share, and subscribe.